We talked a little bit earlier about the difference, or certainly that there was a difference between eBGP, internal BGP, and eBGP, external BGP. And we actually want to, in the next two sections, actually talk about the differences. First, we're going to look at eBGP because this is by far the most common because it's between autonomous systems. We want to look at a working definition of what eBGP is, some unique characteristics of eBGP peers, and finally, how to configure external BGP. The first thing we want to do is have a good understanding of what eBGP actually is and what it means. And the easy way to remember this is external BGP is the relationship between peers in different autonomous systems. For instance, if you look at the graphic here, you have essentially, if we had multiple routers involved in our lab, it would look somewhat like this. Notice in this first circle up top, the very bottom router and the top router of the bottom circle, those are in different autonomous systems. They have direct relationships, and so they have an eBGP relationship. The other ones obviously are within each autonomous system. Those are eBGP relationships. Autonomous system numbers can be used in the range between 1 and 65535. Now, just as there are private IP addresses, the 10.0.0.0/8 range and so forth, there are also private AS numbers. The IANA, Internet Assigned Numbers Authority, has identified private AS number ranges from 64512 to 65534, and you'll notice the ones that we're using in the lab are private AS numbers. eBGP peering is done on directly connected addresses. Now I talked earlier that it's not required, but if they're not directly connected, you have to use the eBGP multi-hop command because the TTL, the time to live between routers in BGP, is set at 1. And if you need it set to more than 1, you do eBGP multi-hop and then the number of hops. There are some unique characteristics of eBGP peers distinguishing it from eBGP. First of all, the next hop address of a peer has to be known or reachable to the router. So in other words, if the next hop address of the peer is not known or available to the router, it will not establish a peering session. That may require use of an IGP or a static route if it's not directly known. For instance, if it's not directly connected, obviously it needs to know how to reach that next hop address. Otherwise, the relationship will not happen. And by default, eBGP peers don't have any restrictions on routes sent and received, other than is it known in the routing table? In other words, has it been configured? And unless you have some type of community setting set. By default, BGP peers do not have any visibility into the internal topology of the peer's AS. The router at the bottom doesn't know anything about the internal topology of AS 65000 unless something's configured that tells it that. But by default, it's not going to know that. It's only going to get what's been announced to it from the peer router. And synchronization with an IGP is not required for route reception or propagation. Configuring eBGP is extremely straightforward. It starts with we talked about before, under the BGP process, the neighbor, the IP address of that neighbor, remote AS, and then what the other AS is. For instance, if we're just assuming router 1 and the internet router here, you do router BGP 65001, and then neighbor and whatever the IP address on the other is, remote AS 65000, and in addition, you could do the same thing inversely from the other side. If you want to specify the addresses being used for updates, in other words, you don't want to use the directly connected interface, you can use the update source command. Frequently, you can do that with loopback addresses because loopback addresses do not go down. Again, if it's not directly connected, you want to use the eBGP multi-hop command and then specify the number of hops. If you don't specify the number of hops, it's going to put 255. So you want to make sure you specify so that you don't make the scope of that too very far.